Um, Thank you very much for joining this talk. In the next 30 to 35 minutes, we'll be talking about software updates with Rauch, the Yocto Project, and OpenEmbedded. My name is Anavi. I'm a software engineer working for Kusuko Group. This is a service company specializing in embedded Linux and open source software development. We have experience in hardware and software build, design, development, and training services. You have already seen presentations at the Yocto Dev Summit by my colleagues Paul and Scott. The company is based in San Jose, California, but we have an engineering presence worldwide, around the world. I'm personally based in Bulgaria. This is the most important slide of this talk. I was a little bit nervous after preparing it. Now I'm happy to proceed with the agenda and to let you know that all the slides have been already uploaded to the website of the event, so you can download them at any time. So the agenda is a brief introduction to software updates, specifically about Rauch. After that, I will show you a Rauch practical example with a Raspberry Pi 4. Finally, we'll talk a little bit about Eclipse hawkBit. We'll wrap it up with conclusions and Q&A session. I'll be tonight here after the end of the official of the conference, so I'll be able to answer questions after the talk as well as in the chats. So let's talk about software over-the-air updates and software updates of embedded Linux devices in general. There are 4 common strategies. The first one, on which we'll actually focus today, is AB updates. This is a dual redundant scheme, which is done by Rauch as well as other solutions such as Mender. The other option is delta updates. In this case, we have just binary delta of the difference between the file systems that are deployed. The delta updates are smaller. This is the advantage of the delta updates. Also, there is a strategy based on containers. Such a solution is Balena.io, and there are also combined strategies. Speaking about combined strategies, this is something that I see nowadays happening more often. So basically, the idea is that you have a very small minimal image as a base Linux distribution built with the Yocto project. With the integration of the meta-virtualization layer, you can add containers, for example, Docker. So you can have, for example, AB update of the base with Rauch or Mender and Docker images running and updating on top of it. There are many solutions for software over-the-air updates nowadays. A couple of days ago at the Embedded Linux conference, I had a talk doing an overview of most of them. This is a short list of some of the common open source alternatives of Rauch. We have various technologies using either AB updates, delta updates, container-based strategies. It's a huge variety. Today we're going to focus on Rauch. Rauch is a lightweight update client that runs on the embedded Linux device and reliably controls the process of updating the device with the new firmware revision. Furthermore, Rauch also provides the tools which we use on the build system to create and spec and modify updates. In the Rauch world, the updates are provided as bundles. This is the keyword, a Rauch bundle. It brings the update. One of the main advantages of Rauch is that it's secure because it uses cryptography to sign the update bundles. And later on in the practical example, you see how this works. Rauch is compatible with the Yocto Project and OpenEmbedded. Of course, the focus on this talk will be on the Yocto Project and OpenEmbedded. However, it's also compatible with PTXdist and Buildroot. Rauch is 5 years old. It was created by Pengatronics, and I believe the founders of the project from Pengatronics are actually here at the Yocto Dev Summit. I rely on them if there are a lot of hard questions to help me. So it's a project that is actually there have been a lot of talks. This talk is actually, although it made it to the intermediate track of the Yocto Dev Summit, I think it's more like for beginners, because I'll show you the exact steps how to get started on a Raspberry Pi. Now, Rauc has 4 components. They're available in GitHub under different licenses. Rauc itself, meta-rauc, which is the Yocto OpenEmbedded layer, which we'll be using for the integration. Also, Rauc is compatible with hawkBit, and there are adapters and plugins for hawkBit. meta-rauc is, as you have seen, it's available at GitHub under a mid license. It supports all recent releases of the Yocto Project and OpenEmbedded, including the long-term supported release Delphi, as well as the latest and greatest Gattersgar. There are more than 20 contributors. Of course, the leading contributor is the co-maintainer and the founder of the project, Enrico. Here I have to say thank you for making this. It's a great project. In order to integrate Rauc, there are several steps that we have to do. This is a tricky part. Here is a summary of these integration steps. First of all, we need to select an appropriate bootloader. Then we need to enable Squashfs in the Linux kernel configuration. This is required because the Rauc bundles, which I mentioned previously, these are the bundles are the actual artifacts that provide the update. They require Squashfs. In our case, using Raspberry Pi 4, we need to switch the boot file system to X4. Rauc does not support X2 or X3 file systems. However, there are some other file systems except X4 which are also supported. We need to create specific partitions and to define Rauc slots. In the example that I'm going to show you, we will use the most simple strategy where we'll have A and B partition which are exactly symmetric, exactly the same. After that, we need to configure the bootloader environment and create a script to switch between the partitions and the slots that we have designed. Probably this is the most important part of the whole integration step. Last but not least, we need to create a certificate and a keyring to Rauc's system.com. This is actually quite easy because meta-rauc provides a script to do this. So now we'll do an example with the Raspberry Pi. Those of you who know me know that I love Raspberry Pi. I'll be using Raspberry Pi 4 for this example. The whole example here is described in a blog post in kusuku.com. The source code is available in GitHub, so anyone can grab it, give it a try. And we can also eventually feature it to other boards because it's I believe it's a simple example to get started with Rauc. So here are the steps. I'm just showing you the exact steps. So pretty much you can hopefully you can just copy and paste them and get the image and do the things that I'm going to do. It should work out of the box. The example is based on release Delphi. The first step is to download Pocky, Meta OpenEmbedded, and Meta Raspberry Pi. Of course, Meta Raspberry Pi is the DSP layer that we will be using for the particular target, the Raspberry Pi. After that, we need to download Rauc-related layers. The first layer is meta-rauc. The second layer is a layer that I have created. It's called meta-rauc community. At the moment, the only integration in this meta-rauc community layer is for Raspberry Pi 4. Hopefully over the time, if I have time, I'll add support for other ports. After that, it's a very straightforward procedure. We need to initialize the build environment as we are all used to. Then to add the layers, this is the long list of layers. We need MetaPython, meta-networking, meta-multimedia, and meta-OE. Of course, I've already mentioned meta-Raspberry Pi, which is the DSP layer, and the 2 meta-rauc layers. So now this is the interesting part. After adding all these layers, we need to also alter local.conf. You can just paste these instructions at the end. Here with blue, I've highlighted some of the more important configurations. Of course, all of them are important. The first one is setting the machine to Raspberry Pi 4, as this demo is particularly for Raspberry Pi 4. After that, I'm switching to systemd. I'm adding rauc to the image. I've mentioned that we need export file system, and here you see that it's defined. Also for the Raspberry Pi, just for convenience, I'm enabling the serial communication over UART. Enable UART is a specific configuration coming from meta-Raspberry Pi. So is the AirPi use U-boot. We're switching to U-boot. This is the bootloader that we will be using. Rauc is very dependent on the bootloader, so this is an important configuration. And last but not least, here I'm setting the the Kickstarter file in this WPS file variable. This is a Kickstarter file that is coming from the meta-rauc community. It has been defined. It has a very simple definition of two partitions, which we'll be using for the AD updates. So now we're building a minimal bootable image by typing a bitbake core image minimal or core image base. It's a good project. After that, we're flashing this image on an SD card. We have to plug it on the Raspberry Pi, attach a serial cable to monitor the booting screen, and to turn on the Raspberry Pi. Hopefully the Raspberry Pi would boot. This is the expected result. And the next step would be to create a rauc bundle. I've already created a recipe, and this recipe contains the instructions how to make a rauc bundle. So in conflocal.conf, I'm just adding nano as a small package that I would like to include as part of the update. I'm building the update bundle. After that, on the build system, I'm using Python 3. I'm starting the simple HTTP server, and with this HTTP server, after accessing it, of course, the Raspberry Pi and the build machine must be in the same network. After that, on the Raspberry Pi, I'm downloading the rauc bundle that have been built on the previous step. I'm installing it with the rauc install command, followed by the path to the bundle that I have just downloaded. And after that, I need to reboot the Raspberry Pi in order for the update to take effect. Just to note, using the same procedure and the same bundle that we have generated on the previous slide, I can flash the bundle on the bundle file on USB stick, plug it into a Raspberry Pi, and do the same thing. This is a manual installation of the bundle using the rauc install command. This is a screenshot taken from the documentation of rauc, which, by the way, is an excellent documentation, and it explains how the things work. So at the beginning, on the first boot, we are booting in partition A. Then when we are executing the rauc install command, rauc takes care of flushing the content of the rauc update bundle to the B partition. After that, we are rebooting when this is done. And finally, the bootloader is responsible for booting the B partition, of course, if everything is okay. And if something goes wrong, we still have the A partition. So as a fallback, it's still a bootable partition. This reduces the risk of having a bricked Raspberry Pi or embedded Linux device. So this is a screenshot that I have taken after performing the update. So on the first line here, you see that I have nano installed. The update bundle has been successfully installed. It's here. After that, I'm checking with the rauc status command. I'm checking the status of the both partitions, and both are okay. And at the moment, the B partition is booted because this is after executing the rauc update bundle. So these are the exact steps how to do it using the layer that I have created. As I told you, it's a super simple thing. It's just to get started. The whole point of this layer was to provide a simple example. So it's convenient for beginners. And in the next few slides, I would like to explain how it actually works by having a look at the source code available in this meta-rauc community layer. The important things, first of all, the U-boot environment variables for RAW. The boot order, it's a space-separated list of boot targets in the order they should be defined by RAW. And the other important route variable, the other important U-boot environmental variable for route is boot underscore the boot name underscore left. It contains the number of the remaining boots to attempt and to find their respective slot from which to boot. Here is a link to documentation route with more details about this. And this is the script that I have created, the U-boot script that I have created to perform all this. In blue, you can see these variables and how U-boot is going to go through the available RAUC slots, try them, and boot the appropriate partition. All this is available in GitHub. It's Oktoberfest, so contributions and GitHub pull requests are always welcome to improve it, to make it better, or to add support for new machines. Another thing is Squashfs. At the beginning of the presentation, I've told you that Squashfs is required for the update bundle. This has been already integrated as part of the kernel, booted with this meta-rauc community layer for Raspberry Pi. Here is how it happens. Here is BBAPen file for the Linux Raspberry Pi kernel recipe, which is coming from Meta Raspberry Pi. And here is how we're setting the Squashfs and the loopbacks configuration variables in the kernel defconfig. I've also needed to generate certificates and keyrings for RAUC. So there is a script called OpenSSL CA. It's part of meta-rauc. I've already created some sample certificates. So if you are using my layer, one of the important things is to generate your own certificates and to make sure that you have this unique security for your devices. More details are available actually in the README file, which is provided as part of the script directory in meta-rauc. And this is the recipe that generates the RAUC bundle. On several occasions, I've already mentioned the RAUC bundles. These are the artifacts that we install on the device, either over the air, or over an Ethernet cable, or using a USB stick. It inherits the bundle class. This class is coming from meta-rauc, and there are certain variables that we need to set. Of course, here you can see the RAUC key file and certificate that I have explained you how to generate in the previous slide. One more thing, and it's about Eclipse hawkBit. So in the example that you have seen, it was a very, very simple example where we were manually executing an update. However, of course, in the real world, if you have a fleet of devices, a lot of Internet of Things, you need a way how to manage all of them. And Eclipse hawkBit is a domain-independent backend. It comes with a web interface, and it's suitable for rolling out software updates to a fleet of devices. It's domain-independent, which means that it can work with various systems. However, it's recommended for RAUC. It's also compatible with software update. You can learn more about hawkBit at eclipse.org. It's a project of Eclipse. Here are a couple of screenshots. These screenshots are taken from the hawkBit documentation. And here you can see how you can both manage the update bundles, the artifacts that are deployed on the embedded devices, as well as the devices itself. And this was it. I hope you've enjoyed this talk. Just to wrap it up with a little bit of conclusions. As you have seen, RAUC is a secure and reliable free and open source framework for AV software updates of embedded Linux devices. The use case that I've demonstrated is the most simple, the most basic use case when you have two symmetric partitions. Rauc provides the tools to generate bundles for the update, which are part of the whole integration for Yocto through the meta-rauc layer. It also provides the rauc tool on in the command line on the embedded device to perform the actual update. One of the things that you should have in mind that if you are using rauc for a different target, not a Raspberry Pi, most probably you'll be using it for another device, you need to go through all these specific steps to integrate rauc for this device. This is the specific thing that you should go through the steps that I've explained you and apply them for the device that you have. Furthermore, you should have recipes to create rauc update bundles and using them to generate the new artifacts which you update either manually, as I showed you, or using something like Eclipse hawkBit. And Eclipse hawkBit is a domain-independent backend framework, which is appropriate if you want to have a web interface and manage multiple devices and multiple update bundles. Thank you very much for watching this talk. Here are a few useful links. The first one is the website of rauc. The second one is an article which I wrote a couple of months ago. It's posted at consulco.com, and it has the exact steps, pretty much the same steps that I've showed you here and explained in more details. How to build an image with rauc for Raspberry Pi, how to boot it, and how to perform a simple update. There have been a lot of talks by the founders and the maintainers of rauc over the years. Here are a couple of interesting talks that I've selected. The first one is from Embedded Recipes 2019. The second one is from FOSDEM 2017. Both show internals and details how you can use rauc. So thank you very much, and I think we still have some time for a few questions.